Hi there, my name is Roelof Temmingh. Today I'm going to talk to you about saving web pages, capturing web pages, putting web pages onto your computer. First, I'm going to tell you just a little bit about myself. I'm from South Africa. I studied electronic engineering. That sucked. It was really difficult. I don't know why I did that. After that, I started a company called SensePost, which is now Orange Cyber Defense with Shelf and Vault. I was there for 7 years doing pen testing and breaking into things. And then after that, I started the company called Patava, which is better known for making a product called Multigo. I ran that company for 10 years and then I left. And then I started Vortimo, which is what I'm doing right now and what this is all about. And if you add all of those years, you get 20 years, which is a lot of years, which makes me officially old. So my background is in IT security and software and OSN, and that's kind of what I do. Okay, so today I want to talk about the capturing mechanism within Vortimo, right? So Vortimo does a whole lot of different things. But one of the things that it also is doing is capturing web pages to your local computer. And we set a pretty difficult criteria for doing this. Like, firstly, we wanted to save these pages all the time. So it's not just when the user click on save the page or something like this. It should automatically save the pages whenever you're browsing the web, right? And it has to work for all sites. It can't just work well for like certain sites. It has to work for all sites, which is a difficult thing to do because we don't have all sites. And it needs to be automatic, unattended, like I said, and it needs to be unintrusive. And I mean unintrusive as in it can't be too difficult. It can't be too hard on the computer to do it. So we can't have crazy CPU resources or disk space. It can't be like every time you browse somewhere, it's 5 gigs of data that's been stored. And it has to be completely local, so no cloud stuff. And the reason for that is basically because a lot of people are kind of sensitive about sending things to the cloud, and they can't send investigations up to the cloud. It's just how it is. So we're going to use a bit of terminology in here. The first is a snapshot, and a snapshot is really the web page in HTML. We're going to talk about that later. Plus the text on the site, plus what the site looked like a snapshot, like a JPEG picture of what the site looks like. And a visit is really that snapshot during a certain time, on a certain URL, and scroll down, a scroll position that says how far on this thing have we scrolled down. And you'll see why that's kind of important to us later on. Now, when you attack this problem, you say we need to solve the problem of being able to properly write web pages to your hard drive with the criteria that we explained. These are the tools that are available to us to attack this problem. We decided to do it in Chromium browsers because there's a lot more tools available. And we're going to use a lot of the APIs, right? So the calls that we're going to utilize is one to save a web page as MHTML, and MHTML is basically just like this portable web page. It means if you take a web page and you save it as an MHTML file, you can give it to someone else, and it will contain all the images and all the CSS and the HTML and everything to basically re-render that page again. Most importantly, it does not contain the JavaScript. So it doesn't contain the JavaScript that's on the page, but it gives you the ability to re-render the site on your browser the way that it was, right? We also get a JPEG of the rendered window, so we can basically see what it looked like, right? And we can parse the DOM. Now the DOM is the what is a document object model, which is basically the page of the document. And so we can parse that entire thing and we can get the text from it. So there's a lot of commonly used libraries available to just parse a web page for text. That's what we do. So we see the text that's on the screen. So we have the text, we have the picture, what it looks like, and we got all the CSS, we got the images and everything to basically reconstruct that page. That's what we get from the browser. We don't need to do any of that work, right? And you'll see that there's basically, we said level 1 to 7, you know, there's a whole lot of different pages on the internet, and how they're constructed differ between different sites. You get something that's really simple HTML. You get pages that are mostly HTML, but that are also populated with JavaScript for some parts, and then pages that are mostly just JavaScript and a little bit of HTML and a lot of CSS. Then you get infinite scrollers. You get infinite scrollers that unload stuff at the top. We're going to talk about that a lot. You get reverse infinite scrollers like Telegram. And, you know, who knows? One day we're going to have, like, you know, some pages with side scrollers and mirror link and holographic displays, and then maybe we'll have a patch for Temmingh that we can also index those pages. Now, okay, what are the parameters that we get from the Chromium browser? We get the URL. We get a whole lot of information about the tab. So we get the tab ID. We get when we get notified if the tab is open, or when a new one is open, or when the tab is closed. There's this thing called the document ready state flag, which we're going to talk about just now. We have a thing that's called the DOM mutation observer, which sounds like a horror movie, but really what it is it tells us when the page have changed, that when the DOM has changed, right? We get the window size and the page size, which you'll see later on is pretty important to us, right? And we get, like we said in the past, the HTML, JPEG, and the text, right? So now let's see, how can we put these things together in a way that we can save pages with all of the criteria that we discussed in the past. Okay, so now the first thing that you kind of got to consider is when to save the page. So you would think that it's pretty easy. You look at the document ready state flag, and when that flag drop, it basically tells us all the content is loaded, the page is now good to go, and then you save the page. And it kind of works, but it works for a very small percentage of the internet. Basically, it works for any kind of static HTML site. But as soon as there's JavaScript involved, it doesn't work anymore. And the reason for that is because the page might be finished loading, but the JavaScript loads content into the page much later, right? So you take a snapshot of a blank screen. The content isn't loaded yet. So as a start, what we need to do is we need to wait a little bit before we basically take the snapshot. When the document ready state flag drops, you got to wait a bit and then take the snapshot. But if you know anything about programming, you'll know that hard coding a value like that is a really bad idea, because what happens if it takes a little bit longer to load the JavaScript, for the JavaScript to load the content? Then you basically take a snapshot of a blank page again, right? So it's not a great idea to only rely on a delay after you save after the ready state flag is dropped, right? We have it, but you'll see that we use a whole lot of other things as well. And here you can see what it looks like when you basically take a snapshot of an empty page. This is what it looks like on Twitter. Twitter does a whole lot of crazy shit, and if you're just waiting for the ready state flag to drop, you'll take a blank picture, right? Okay, Now let's talk about DOM mutations, right? So you might say, well, I've got a different idea. My other idea is, let's just see if there's DOM mutations. And when there's no more DOM mutations, then we know that the page is now in a stable kind of form. And then we can take a snapshot because nothing else has to load. And that seems like a great idea. But your user can go to the site, and as soon as he goes into the site, he starts scrolling down on the site. And then the DOM mutation is basically just like going like flickering on and off all the time, right? So then you can say, well, but maybe that's not such a bad idea. And then it's not such a big deal because we can just overwrite that visit every time. So we overwrite the visit every time, and there's more information as he scrolls down, the page gets bigger, and there's more information, and we basically just overwrite this every time. But that is a lot of that is resource intensive, right? To save the file is a lot of work, and so we don't want to save the file all the time. So what we're going to do, what we have as a start, is we have this thing called a throttle that basically says you can only save the file once in this case 3.5 seconds, right? You can't override it all the time. You can't be overriding the file 10 times a second. You can only do it once, and the default is 3,500 milliseconds, right? And it has that effect of a low pass filter. It's basically saying this when that event fires like 5 times in a row, we're only going to fire it one time, right? Okay, so it now becomes a situation of when to create a new visit and when to overwrite the old visit. Okay, so let's think about what we have so far. We say if it's a new visit when the tab ID change. So, we open up a new tab, then we have to create a new visit. We can't overwrite the old one because you'll be overriding the previous, page that you've been to. Or when the URL changes, which seems like a good idea, or when there's content unloaded. And we're going to talk about that a little bit later. What happens when content gets unloaded? But for everything else, we overwrite the visit, given the restrictions that we've now had, like low pass filter on saving the page all the time, on DOM mutations, and on the ready state when the ready state is dropped after a certain while time. Given all of those restrictions, we will overwrite the visit every time, and that seemed to be okay. And that would be the end of the talk, but it's not, because there's this thing called infinite scrollers, and infinite scrollers basically load content at the bottom as soon as you hit the bottom of the page, right? And that triggers the DOM mutation event, which is now the page has changed, right? And the ready state flag changes, and we overwrite the visit, and then maybe that's okay. And what seems to be the problem? Well, the problem is that infinite scrollers also unload stuff, right? So let's look at unloading. In order to save resources, infinite scrollers basically unload the stuff that sits at the top, right? So you see this on things like Facebook, Instagram, Twitter, and you can even see it if you manually save the page. If you manually save a page and you've been scrolled down a lot, then that content is the content that's at the top is not there anymore. Okay, so I'm going to show you what happens when you scroll down on Twitter. I'm going to take this page and I'm going to pick something that is pretty unique. So golden chips. So if I do a search here for golden chips, you'll see that it pops up, right? There it is, golden chips, 1 of 1. Easy. Now I'm going to scroll down, and I'm scrolling. Okay, and let's say this is far enough. Let's say I'm scrolling to this point, right? Now I'm going to search for golden chips again. So I do Control F. I'll search for golden chips, and what do you see? 0 of 0. This means that part of the page is no longer in the browser's memory. It's been unloaded at the top, right? If I save this page, let's say save as, and we say single file, Twitter, save it. That's the MHTML file. That's what we save as well, right? So if I look at this page, and I put it in here, then you'll see there's a lot of blank space here. Lots of blank space. In fact, I can scroll there. I'm scrolling down on the right. Oh, there we go. And there is the page. There's the window of the page that you're seeing, right? That's how much your browser is basically keeping in memory. This part here is also blank, right? The rest of it is being unloaded, and that's to save resources. So you won't even see it here. So if you're going to save this just by yourself, you've missed all of this stuff at the top. So how do we handle this, right? So we basically have to save multiple snapshots of this page as the user scrolls down. So imagine, like, in the past, you've had these old sites that had like page 1, page 2, page 3, and a little, arrow on the side, and you go to the next page, and you go to the next page. When you reach the bottom, you go to the next page. And you can kind of almost see that infinite scrollers can be treated like that. So you're on page 1, you scroll down, then you're on page 2, scroll down, you're on page 3. And so you have multiple visits, multiple snapshots for every certain amount that you browse down, right? And there might be a little bit of overlap between these pages. So, you might have that the bottom of this page and the top of the next page is kind of the same, but that's okay, because you're actually not missing the information. You're not throwing information away. You have a little bit of overlap, but you're not discarding any information, right? And that's what we're worried about, is that you lose information. So this is from the interface, and you'll see here we have, as you scroll down, you have multiple visits for a timeline on Twitter that you've been scrolling down for quite a bit, right? So now just to recap, right? We know that if we are unloading, if there's unloading happening, we want to save multiple snapshots, right? Because we can't save one, because then we're going to miss information at the top, right? So we want to save multiple snapshots if there's unloading happening. But if there's no unloading happening, we don't want to override. Then we want to override the snapshot. We don't want to then save multiple snapshots, right? Because imagine you have something like the Facebook friend page. Now, Facebook friend page, actually, they don't do any unloading at the top. They just make the page grow bigger and bigger and bigger. And if you have something like that, and you just see that it's an infinite scroller, then you'll have multiple versions of that friend page. And that's not what you want. You only want one page for that. So we got to find a way to know that there's unloading happening at the top. Now, how are we going to do that? The way that we do that is we say, well, we got the text, right? So we got the text of this page. And then when you scroll down a little bit further, we have the text of this page. Now, if all of the text that's on this page is also on this page, well, then there's no text missing, right? But if the top was unloaded, like this part of my hand this part was unloaded, right? Then this stuff is not on this stuff. Then there's a difference between this. This is like this, and this is like this, right? And there's things missing. This part here is missing there. And then we know that, hey, there's been unloading happening, because the content didn't get bigger, the content got different. And content is now different, right? It's not, we can't find it anymore. And so we have these things that we basically do this text compare and decide if there was unloading happening. If there's more than 60% of the old snapshot missing in this, we say, hey, you've been unloading. We've got to make a new visit, right? Okay, but doing this is kind of expensive to do. It's an expensive operation to do. And so a lot of sites change the content really rapidly. It's unbelievable what you find on the internet, especially news sites. So you end up with a lot of duplicated visits. So we need another condition to determine when to do this test, when to do this text compare, right? And there is this thing that allows us to get a clue that it's going to happen soon, and that is when the page size changes. So on a lot of these infinite scrollers, when you scroll down, you'll see that the scroll bar, it's big, and then it starts getting smaller and smaller, and that's because the page size is changing. They update the page size. So for us, that's a clue to say, hey, but there's been possibly unloading happening. So quickly compare the text and see if there's a difference, and if some of the text is missing. And if some of the text is missing, we know that it's unloading. We know, hey, we gotta save a new visit. We gotta make a new visit, right? So you'll see that in the tool, there's actually this thing called the minimum scroll difference, and that's in pixels, right? And if there's more than 750 pixels change on the page size, that's going to trigger an event whereby we see if there's unloading, and if there's unloading, then we're going to decide if we want to, then we're going to decide to make a new visit, right? Given all of the restraints that we have, the document ready state, the DOM mutations, all of those things also gets into play. But in certain cases, you can't detect the unload. And that is because there's no text. There's no text to trigger on. So let's think about a site that uses infinite scroller where there's not a lot of text. And that would be Instagram. On Instagram, if we scroll down on Instagram, we just see pictures. This is pictures and pictures and pictures. There's no text that we can be like, hey, actually, no, there's a change in text. And so we need to find a way to basically tell the tool, well, if you're on this site, it is unloading content, because Instagram is unloading content at the top, right? You have to save multiple visits, regardless of the fact that there's changes in the text, because you're not going to see any changes in the text, because there's no text, right? And then we just decided, well, you could just put it in a list and say, if you're on Instagram, it means when you put this into this field that says override auto unloading detection, which nobody knows what that is. A normal user look at it and they go, I don't know what this is, but now you know what it is. It basically just means the site is unloading content, but there's no text, so make multiple visits when you see that the page is getting bigger, right? Right, so what is the bottom line? Bottom line is preserving web pages on the internet is not easy to do. And it's not easy to do when you want to have that design criteria, if you want to meet all the factors in that design criteria, right? And it kind of feels like you're trying to take a photo of a dynamic event. It's like saying you got 14 frames of a film camera and you got to record a soccer match. Show me all the goals. And, sometimes you take the picture because they were close to the goal. You think, oh, they're going to score now, and then it didn't happen. And then, you took 2 photos of just the grass, and it's a difficult thing. And so maybe we must think about capturing video rather than snapshots. It feels like we're trying to capture a dynamic event in with a static mode. JavaScript counting down from 100 to 1. What are you going to save? What is the snapshot going to look like? At what number do you want to see that web page? Because remember, we don't save JavaScript, right? And so it becomes this delicate balance between duplicating content, e.g. having multiple of the same thing because you don't know it's the same, or that you're missing content, or that you're having too much, or you're using too much resources. You're either using too much CPU to constantly compare things and see if it's different, or you interfering with the browsing experience by putting a button down that the user got to click on, to save the page. Nobody wants to do that, right? And it is kind of like, the programmer's credo is something that became my friend during the journey, building this, which is, we do these things not because they're easy, but because we thought they were going to be easy, and they're not. But once you've done all of that, and once you've done all of the hard work, it's like, then you can have your pudding. And your pudding is things like, well, we can extract images, and from those images we can extract the EXIF, and we can make the user search on the hash, because we can get the hash of the image, and we can make the user search on the EXIF, and we can extract objects, and we can enrich the objects with APIs, and we can show a heads-up display to the user in the browser and show them where they've seen these things, and we can make graphs. And those are all the fun things we can do once we've been able to capture web pages efficiently. So I hope it's been informative to understand that it's not easy to save pages, web pages, and I hope you enjoy this journey with us. Thanks.